at the top of the page, so today we're doing the application piece, so putting it all together, and if you read the bullets, when it comes to the state test, you have to be able to recognize the function that you're going to use, okay? You want to determine whether you need to show the work algebraically, or can you graph it. If it doesn't specify a method, then you can do whatever method you want, okay? The third bullet, answer all questions that are asked. So read through the questions several times to make sure you have done this, and pay attention to all the details, especially your units. You got to make sure you include a unit of measurement. Now I asked this question earlier. When you see a question like the two we have in our notes today where it has 1A, B, and C, and on the back it's 2A, B, and C, and it could be broken down into even parts D and E. When you see a question, one question broke up into multiple parts, how many does it tend to make you more anxious or nervous to even start the question because it is broken up into parts? Anybody? Sometimes? Yeah. So just think of it as though they could say, you know, question, it's going to be a short answer question, so maybe it's 24, 25, and 26. Look at it that way. And just know, too, that if you screw up part A, but you do parts B and C correct, based on your work in part A, you're still going to get credit for B and C. You'll just lose a little bit of points for part A. Okay? So take a minute to read the example to yourself, underline some key phrases, and then we're going to start with part A, which is the graphing. Okay, so what I like about this question as well is that the axes are already labeled for you. You have a scale on the x and y axes, and it tells you that your x-axis is the number of products in hundreds, and the y-axis is cost in hundreds. So we have a company that's considering building a manufacturing plant. What is the cost at each plant? And based on the plants, okay, and their prospective costs, when you go to pick which plant, if you were the CEO, would you consider building? Cheapest. The cheapest, so the one with the lowest cost. That got some people caught up this morning. It's not a profit, it's a cost as your variable, okay? So graph. So our two functions, a of x equals 3x squared, and then the other one, b of x equals 8x plus 3. So one's a quadratic, one's linear. Okay? When you go, this obviously tells you have to graph, so it's not going to be an algebraic solution. But when you go to make your table, instead of doing x comma y, if you did x and then a of x, it would be clear that that's the table for the 3x squared function. And then the other one, if you did x and then your table b of x, it would be clear that that's the linear function. And you don't have to use a table of values to graph a line. You can just use your slope and y-intercept. But the points, note, we're in the first quadrant because we don't have a negative number of products or a negative cost. So your values are going to be 0, 0 for the 3x squared. 1, 3, 2, 12, 3, 27, and 4, 48. And you can keep going. Okay, so let's plot those points, and then we'll look at the linear function. Each tick mark on your y-axis is counting by 2's. So if you want to fill those in first. So 1, 3, that's going to be in the middle of the 2 and 4. Now, because try to draw a smooth curve the best you can. And because it didn't say it wanted a domain of only from 0 to 4, we need to put the arrow. So I'm going to label this, you could call it a of x and write the equation, but I'm going to call it, this is going to be for site A. And now I'll graph the linear function in green. So based on the equation, we can see we have a y-intercept of 3. So your first point is 0, 3. Plugging in a 1, right? 8 times 1 is 8, plus 3 is 11, so 1, 11. And then can you see, if the slope's 8, can you see the plus 8 and then your plus 1, 8 over 1 is 8 for your slope? Just making connection of rate of change. So then if we continue the pattern, when x is 2, add your 8 and you get 19. So then be 3, 27, and then 4, 35. So let's graph that. And you should use a straight edge, but I'm just going to sketch it. No, I'll use the line tool since I didn't do a very good job. So part B says to state the positive values of x for which the production costs at the two sites are equal. So I want them to have the same cost, which is your y. The point where both graphs share the same y is the point of intersection. Okay, so that's an x value of 3. Explain how you determine your answer. You could talk about the table of values. So you want to talk about the table of values or the graph part? Okay. So if we explain using the tables, the y values or costs are equal when x equals 3. Or you could say, explain how you know that is the point of intersection of the two graphs. So that's where the graphs intersect. Last part. If the company plans on manufacturing 200 products per week, which site should you use? Should you use site A or site B? If they plan on manufacturing 200 products per week. If you go over to the graph, here's the number of products. Again, we're in terms of hundreds. So this is your 200. So should they use site B or I'm sorry, that's A. I gotta look up here. Should they use A or B? If you actually look at it in terms of points for an x value of 12 up here on your table or on your curve, you've got 12, 2, and that was for site A. And then site B, it was 2, 19. And again, your y value is cost. So you're going to want to choose the site that has the lower cost for that production. So the answer is site A. justify your answer, that was something like this, stating the points. And then you just want to explain it has a lower cost. Last one. Number 2. So same thing, take a moment to read number 2 and underline some key words, phrases. You can use a highlighter. Okay, so the number of units of two substances, X and Y, change each hour. The rates at which the number of units change are described below. So we have two substances, and they're describing the substances, or we're looking at the data of hours and number of units. Okay? You don't see a table for substance Y, but you could make one. So let's make one. So hours and the number of units. So there are 100 units of the substance to start. So at 0 hours, we have 100. And then it says every hour, the number of units increases by 100. So for hour 1, how many units of the substance do we have? 200. Good. And then hour 2? 300. And we could do one more. Okay, so now we have two tables. Part A, does substance A change by a linear or an exponential rate? Explain how you know. And part B, does substance Y change by a linear or exponential rate? Explain how you know. So which one, substance X or Y, is linear?
Y.
Noah?
Y.
Y is correct. So substance Y is linear. How did you know?
Because it changes by the same rate every time. It has the same rate of change.
The rate of changes, yeah. Okay, good, I like that. The rate of change is the same every time, he said. We're also, as X increases by 1, what's going on with the Y values? Are you seeing addition or multiplication? Addition. Okay. The Y values. Or actually, I'm going to use the variable in the problem. The units of the substance are repeatedly adding how many? Good. So I'll leave substance X as, what's going on here with our values? Multiplying by 2. So that would mean it's doubling, which is linear or exponential? Exponential. And we could say the units are repeatedly multiplying by 2. Do you guys want to practice writing the equations? Okay, so if we practice writing the equations for this one, the exponential example, what's our starting value? Yeah? No? The starting value is when we have 0 hours. So instead of multiplying by 2, what do you get when you go backwards or divide by 2? 1/2. Just to give people time to think about it when you yell it out. 1/2 divided by 2. If you think, what do you double to get 1/2, which is 50 cents? That's a quarter. Okay? So our starting value, so we have an equation, y equals 1/4 times, again, doubling, the base is going to be 2. exponential means your variable is in the exponent. How about the linear? What's our slope? What do you see going on with the y values? The y values go up by 100 as x is increased by 1. So 100 over 1 for slope. It's going to be y equals 100x plus, yeah, 100. Good. Now the last part of the question, and the equations might help you. Will the number of units in substance x, and substance x was the exponential one, will the number of units ever exceed or go beyond the number of units in substance y, which is linear? Explain how you know. Okay, to finish part C, this is a response that we put together as well as a graph to model the situation of the number of units in substance x versus y.